Hi, everyone. Welcome to a webinar from AppViewX. The title of this webinar is going to be Automating Certificate Management for DevOps Pipelines. My name is Glenn Gray. I'm a solutions architect with AppViewX. In this agenda, we're going to cover the current state of certificate management as it relates to DevOps. We'll describe some of the PKI risks that traditional DevOps processes pose with relation to certificate lifecycle management. We'll cover the advantages of automated and integrated certificate lifecycle management, how the AppViewX platform can address those risks related to PKI management and the advantages we can offer. Follow that with a brief demo and then open up for Q&A. So one of the first questions that is commonly asked is, where does certificate management fit into DevOps? The diagram that is appearing on this slide is a pictorial representation of a DevOps pipeline or a CI/CD type pipeline, where you're wanting to start by issuing a change. You'll trigger a build, initiate that build, run tests, and then if it's approved, and the deployment appears to be successful, it will move forward. Within that process, oftentimes there's the need to issue PKI or certificate, which invokes requesting of the either code signing or certificate creation instance. Within the traditional certificate processes of DevOps, it can often be a bit confusing or perhaps detached, where you're starting out with the monitoring of certificate instances. Perhaps the expiration is not tracked cohesively. So your DevOps integration can oftentimes lose track of the certificate, or perhaps the DevOps integration does not communicate with the certificate authority. So oftentimes it's detached. Your CI/CD pipeline is not integrated with the PKI administration tasks, and thus you're having to detach from the CI/CD pipeline and rely upon manually driven methodologies and approaches to actually either sign the certificates, issue, request, bind, and get things like code signing or certificate instances that apply to applications within your CI/CD pipeline fully integrated and automated. And this can take, days in order to acquire a certificate or sign code. So some of the potential risks within this this sort of manually driven pipeline can include the DevOps team resorting to some accelerated certificate processing, whether that's self-signed certificates, purchasing their own certificates from CAs, and thus violating the overall PKI management and governance practices. Some of the additional detractors or challenges as it relates to certificate lifecycle management with this manual implementation is complying with that policy structure or governance, as I'd mentioned. There's ad hoc processes that are defined. Perhaps one developer has created a script structure, yet that's not commonly shared around the CI/CD pipeline infrastructure. So the variation in output can prove as a tremendous challenge in maintaining a cohesive and fully compliant certificate lifecycle management. You'll also have a variation perhaps in the cryptographic standards which are deployed. perhaps some of the certificates are being requested and fulfilled with deprecated cipher instances like TLS 1.0 or TLS 1.1, and the desired is TLS 1.2 and higher, which currently, as we speak, are not deprecated cipher instances. And then the manual PKI administration can oftentimes be very error prone. The human interaction may bind instances to the incorrect application instance. This is especially common in load balance application instances. Oftentimes the certificate is bound to an erroneous or a mistake is made and it is applied to the incorrect application instance within load balance environments. An example being like an F5. And then the organization-wide monitoring of the expiration, the bind association to application instances can be a pretty cumbersome task. It's a one-off sort of hunt and hide and seek sort of scenario. You're having to investigate from top to bottom, fully qualified domain name, all the way down to each application instance in an HA environment, go and evaluate what is the certificate instance for this application service endpoint, and then on to the next and on to the next. And then all of these can create either outages, unintended outages, or perhaps data breaches where you have application instances serviced by various certificates, and if a failover occurs, the certificates within your weakest link may have a deprecated cipher instance associated to it. So though you may think that your highly distributed application instance with 4 service endpoints are all protected with a desired cryptographic instance, your weakest link, say 1 out of the 4, being applied with a TLS 1.0 could lead to a potential data breach. So solutions that AppViewX recommends and can offer would be integration within your DevOps pipeline to fully automate the certificate lifecycle, making it available to your DevOps teams as a service. They could use the flexibility to integrate with API of the AppViewX platform. So if they're perhaps utilizing a current automation platform such as a Chef or Puppet for their DevOps utilities, you can integrate directly with those automation tools and the AppViewX platform with a REST API call for performing certificate lifecycle management functions like request, renew, revoke, suspend, reinstate, and so forth. In addition, you have the ability for 100% visibility into your discovery and your certificate holistic views, meaning the ability to identify the chain of trust, the issuing CA, and the endpoints where the certificate resides. It can also support multiple CAs. So if you have internal, external, maybe even multiple external CA instances, each of those can be facilitated and supported so that your DevOps teams have the availability to request the certificates which are appropriate for the application build instance. You also have security and orchestration, the ability to collect your private key structure into a centralized repository and eliminate the distributed private key management system of manual intervention. What I mean there is oftentimes companies will have a requestor who generates a CSR, maybe emails it or places it into a centralized share repository for a PKI administrator to then fetch and submit to certificate authority for signing, and then retrieve the certificate and again place it in perhaps email or another centralized share repository for yet a third party to then bind to an application instance or server or load balancer or firewall endpoint. And when you have that type of workflow structure, it can leave your private key structures vulnerable and exposed. Why? Because you've passed that private key structure between multiple organizational units or users, as well as placed it in multiple locations. Perhaps it's desktops, central repositories, email repositories, and this can lead to exposing that private key and potentially lead to a data breach. And then lastly, the self-service automation, where you ideally want to have only the service request exposed in a catalog fashion for your DevOps and CI/CD pipelines to perform and make available these lifecycle management functions, but keeping separate the protection of the private key and certificate instance itself. The private key instance and certificate could be maintained only on the application endpoint and a centralized repository, as opposed to distributing it through manual exchange. So with that, describing the end-to-end certificate lifecycle management and automation that the AppViewX CERT Plus platform can provide, this graph is, or this diagram is meant to illustrate how all of this infrastructure can be integrated, and through the AppViewX platform and its role-based access control structure, allow for this self-service catalog and continuous CI/CD pipeline functionality to work. In the middle, you have the AppViewX CERT Plus platform, where users across multiple organizational units and functions or technology functions can access through a workflow catalog structure, and then integrate with HSM platforms, multiple CAs, and multiple endpoints where the certificates reside. So on the bottom, you have individual certificate endpoints or application service endpoints like ADCs, firewalls, and servers. You have the ability to communicate with the CA on the right-hand side and issue that CSR, retrieve the certificate, and then bind down to the application endpoint. Also with the ability to integrate with HSM platforms so that you can check in and check out the CSR instance. All of this is allowing and enabling an enterprise to maintain highly secure structures for private key management and reduce the errors that are associated with the manual exchange of these certificate assets. So I mentioned the enhancement of full visibility and discovering and monitoring. A few graphs here are showing screen captures from the AppViewX platform, which I'm going to demo in just a moment, but you have the ability to do centralized inventory reporting, either through dashboard or customized reporting. And you have the ability to define discovery routines based upon various sources being the server platforms where they reside, the ADC or load balance platforms, the firewalls, the CAs, even IP address ranging or subnet. So you're discovering SSL TLS listeners throughout your IP infrastructure. You also have the certificate holistic view and single pane of glass certificate lifecycle management functions. So in a very intuitive, holistic view, you're able to view the certificate chain of trust, all of its PKI related attributes, including expiration, as well as the certificate authority that has issued it and where the certificates reside. And from this single holistic view, you can perform certificate lifecycle management functions like regenerating, renewing, reissuing, and revoking that particular certificate or application instance. The AppViewX platform also offers a automation and visual workflow construct. So in this palette or design palette, you're able to create workflow request catalog items that can be extended or offered out to your DevOps environment for self-servicing. I'm going to describe that a bit more when we get into the demonstration, but this representation is meant to describe how you can create a certificate request form, collecting the details, and that might be common name, subject alternative names, and then standardizing on which CA is going to actually issue the certificate, what the CSR related details, organizational unit, locale, state, etc., email contact, all of those being standardized, but collecting the appropriate details as far as what the certificate common name would be or subject alternative name and where it might reside, right? Which application instance you're wanting to bind to. And then from that point on, you're defining the workflow orchestration to meet your customized needs. That might be creating of a ITSM ticket, like a ServiceNow ticket, requesting of the CA, fetching the certificate, and then ultimately binding it to the application instance, creating an application connector. Now I'm going to jump over to another screen here and show the AppViewX platform within my demo environment. So I've logged into my application, my demo application instance, and I'm going to start off with showing the certificate inventory. First, I want to describe the holistic view as had been shown in one of the slide items. So I have an inventory of certificates. This is the master table. It's showing several columns of PKI related details. Specifically, I have common name of a certificate, any subject alternative names, the device where it was discovered, the file name source where it was discovered, and the device where it was discovered from. It's issuing certificate authority, identifiers such as whether or not it is or is not compliant. So as I look at each one of these and I take an example, this is an Nginx application instance. We also have Apache instances, many that are associated with load balance services. So as I look at one, for example, a QA instance, this particular application is named QA-nginx1.tryappviewx.com. I can see all of the PKI related details from this single holistic view. I see that it is a SHA-2 with RSA and 2048-bit algorithm. I can see that it was issued by my internal Microsoft CA, and it was bound or associated with my ASM or WAF, as well as my LTM F5 instance. This is what we refer to as the application connector. I can push or even roll back. Rollback would refer to I've accidentally pushed an application certificate instance to the wrong location, so I can roll it back or revert. But most important here are the certificate lifecycle management functions of this application instance, where I can regenerate or renew the application. So if it's about to expire, for example, I can issue a regeneration of the certificate and perhaps even add additional common names, subject alternative names if necessary. I can even change the PKI related attributes if I want. Now, this policy has not defined any additional cryptographic elements, so that's why we're only seeing SHA-256, RSA, and 2048. But if I defined a policy where I would allow, say, SHA-512, bit lengths of 4028, 4096, and so forth, I could adjust those and then issue the regeneration. Once you issue the regeneration, you can push it directly to the endpoint or even automate the push to the endpoint upon regeneration. You'll see that in this case, I've defined this particular application connector to push it automatically. So you could fully automate the regeneration and bind of the certificate, the regenerated renewed certificate, to the application endpoint without any additional work. Going back to the dashboard, I had mentioned the centralized reporting and collection. There is the default server certificate inventory dashboard where you're able to holistically look at your entire inventory set, broken down by the certificate authorities that issued them. You'll see that I have an application, I have a CA that's embedded in the AppViewX platform. I have my Microsoft CA. If you have others like GoDaddy, Sectigo, and so forth, all of the certificates that have been issued by those individual certificate authorities are also going to appear in bar charts. I have self-signed certificates, and when I select these items, whether I'm selecting the color code indicator for expired, revoked, actually valid, it will take me back to the inventory view of that particular collection. You see a regex expression that's filtering out only those items which I've selected being issued by my Microsoft Enterprise and those that are valid. But going back to the dashboard view, I can see that I also have report structures that indicate the expiration by month. So as I'm looking forward, we're currently in the month of March. In my demo environment, I don't have any pending expiries until I come up to the point of, say, November or December. And I even am able to view it by those that are set for auto renew and those that are not set for auto renew. So as I look at November here, I have one pending expiry and it is not configured for auto renewal. So I know that this particular one will require some manual intervention because it's not automatically going to renew. So if I wanted to, I could go in and I see that this particular certificate is applied to multiple Apache service endpoints. I can identify that this one is out of sync because it is red. And we see that from the expansion box here, the color code definition, red indicating that it's out of sync. So I could push this particular certificate out to that endpoint directly from this holistic view. And it will go through the request item workflow where I'll need to approve and implement. So it stops at a review point in case you want these particular governance practices to apply escalation and approval. Otherwise, you can set the policy structure so that it bypasses these. This might be appropriate for dev, QA environments, but not for prod. Prod, you may want to have actual approval steps, but you'll see that you're fully automating the push instance for this certificate out to the endpoint. And here it is going through the workflow and initiating the push to that endpoint. You'll see that it's still in progress, but it'll finalize in just a moment here. I can also, again, perform a recreation of this certificate instance by an authorized CA by applying a CA connector. So I'm going to go back to the dashboard here. That was the expiry by month. I can also view compliance. So when I specify a policy, I can define what the policy requirements are. And then as I look at these individual certificate instances which are not compliant, I can identify why they are not compliant. I have one called weak app. And within weak app, I can see that the certificate has been issued with 1024 and SHA-160. However, my policy is minimum of SHA-2 and minimum of 2048. So I can identify this particular application instance, go back to the inventory, and then process it. We also have report by source. So where do the applications or certificates live? Those that are associated with my Nginx, my Citrix ADC, my Tomcat servers, my IIS, Cisco Apache, whatever infrastructure endpoint that is managed, you can view them from this particular graph structure. And again, anytime you select one of the bar charts, it takes you to that specific inventory set, and you can manage that particular categorization of certificate assets. You have instances of orphan certificates. Now, what that means is certificates that are out of sync with the application. Perhaps someone intervened with an application instance and removed its bind association to your preferred certificate instance and applied maybe a self-signed certificate. So you could see those instances where it's out of sync, meaning that at one point it was associated with this certificate and it had been changed at a later time. So when you're looking at this one, for example, I see red on these. So this Apache application connector to these instances are valid because they're green. However, it's changed on these, so I may want to re-push to those endpoints so that it falls back into compliance. Going back to the dashboard, just one or two other helpful summary categories. Those certificate summary reports, those that are valid, revoked, expired, a breakdown by the issuer. So have my certificates been issued by, for example, the AppViewX issuing CA, that is the Microsoft CA, the AppViewX CA itself, and then any others. Now, all of these others that are listed here, you'll see a lot of times they're just self-signed certificates. This particular category is those that are issued by like an ADC. They're just generating a random character string to identify the CA, but this is in fact a self-signed CA. You also have the breakdown by cipher suite. So where you're trying to identify which certificates are deprecated, you can easily identify those certificate instances and then begin to remediate them. So when you have TLS 1.1 certificate instances or even weaker, you can identify those and then remediate them, thus keeping you compliant for, say, PCI and other regulations. One of the last items I wanted to define, actually second to last, that I want to demonstrate here is the studio workflow. And from the slide, that is that design palette where you're creating workflow structures that you can then make available for self-servicing. Now, this self-servicing is available either through the web user interface or a REST API. With that REST API, you can then publish workflow structures or a catalog of service request items through, say, an ITSM like Jira, Remedy, ServiceNow. So you're not driving your members, your users into AppViewX. You can publish these workflows through any available endpoint. One that I think is very easy to identify with is one that's called easy certificate provisioning. So what is the capability that we have here? Defining a collection form for the variables that a requestor is going to have, and then say enrolling the certificate instance and then applying it to an application or creating that application connector. Now, this is the workflow structure where you're simply dragging and dropping these individual tasks in a sequence and then aligning them. Sequence task 1, 2, 3, 4, and that's the entire workflow. Now, what does it look like from a end user perspective? Well, if we go out of the studio design and instead into the request, so when I enable the request from the design view, it's then published. Published meaning it's available for use. So as I look at my catalog, I have a variety of categorization structures. I also have a search field. So as I look for the easy certificate provisioning workflow, I can utilize that particular request item to perform that particular task. So if we look for, say, certificate, a new certificate request item, I can fill in the items within the field structure. And in this case, it's only requiring a minimum definition of what the common name is, select the certificate authority, the hash, key sign, bit length, and then it will generate the CSR and make available that particular certificate instance. You could structure the workflow design either to bind directly to the endpoint or make it available for a download, and then have the developer actually bind it, or system administrator or network operator bind it to the application instance. The concept here is that you're defining the workflow to meet your particular enterprise needs. Now, a last item that I wanted to show, I mentioned that all of this is available through REST API. So just to demonstrate very briefly how that works, I have, I'm just going to demonstrate very quickly the login or retrieval of a session ID for REST API communication. You'll see that it's a post method. You're defining the URL path. And in this case, it's just going to fetch a session ID. Now I've created environment variables to keep in this API test instance. So my variables are just defining, hey, this is the host endpoint. I've put in my username and login, but you'll see that the host variable there and the port that it's listening on is the service endpoint for my REST API. So when I send this request, I get back my session ID, and that session ID is retained for all subsequent request items. So if I'm doing things like listing certificates by a search value, I can go and issue an additional request item. Again, the same construct. It's a post method to the URL, utilizing the gateway key that I fetched. And then I can specify what is my search criteria. And again, I've created environment variables to associate to this particular request item. And again, searching, sending. In this case, I didn't specify a search value. I was looking at a wildcard, right? That's a regex wildcard, but you'll see my entire data set has returned every certificate instance within my database. But here you're seeing all of the certificate related attributes. So it's very flexible, very powerful. So if I'm just doing search, or I'm trying to reinstate a certificate or renew or reissue, regenerate a certificate, all of this is available within not only the web user interface, but REST API. So you can extend and create your own structure of API queries. In addition, every service catalog item is also a REST API request. So any of these certificate lifecycle management functions that are made available within the service catalog are also available through REST API. So with that, I would like to open it up to any questions. Feel free to post those questions in the Zoom meeting Q&A. Looks like we have a question posed into the chat, so give me a moment and I'll share that. One question is, does the AppViewX support Acme? Yes, it supports Acme, EST. The AppViewX platform has an embedded Acme listener. So if you're wanting to integrate with, say, HashiCorp, which is a very common HSM platform, and we can integrate with resources like that, which leverage the Acme protocol to initiate CSRs and certificate management request items. So the HashiCorp instance may generate an Acme call over to the Acme listener on AppViewX and process that for signing by the CA, retrieving of the certificate, and then posting back to the HSM instance. Another question we have here: can my DevOps team use OpenSSL to generate self-signed certificates? Absolutely. The AppViewX platform utilizes OpenSSL internally for the CA instance that AppViewX offers. So at its base, it is an OpenSSL provider as well. The AppViewX platform is built on Linux, so it has OpenSSL embedded within the Linux platform architecture. Another question: I use HashiCorp Vault for getting subordinate CAs and self-signed certificates. Is this a good practice? Yes, it is a good practice. When you're centralizing your private key structure management in HSM platforms, or even software HSM platforms like the HashiCorp Vault instance, it only enhances and hardens your overall threat platform, your threat surface. So it's definitely recommended. And as I was describing just a moment ago, how that integration could occur by leveraging HashiCorp and its Acme request or use of the Acme protocol. What's wrong? Another question is, what's wrong with using self-signed certificates to secure containerized applications? Well, there's really nothing necessarily wrong with using self-signed certificates, other than the fact that maybe many of your application consumers, browsers and whatnot aren't going to trust those self-signed certificates. So you get the prop-up within a web browser or an application instance, unless you bypass validation of the certificate signer, that it's not trusted. That's really, the drawback there. So when you're using self-signed certificates, unless you're creating your own self-signed certificate authority and adding the root into your application request store's trust store or browser trust store, then you're really not going to know who has signed that certificate, and that can be compromised. Any other questions, thoughts? We have about 5 minutes left. Just wanting to respect the time specification that we had allocated. Well, if there are no other questions, I want to thank everyone who has attended Please don't hesitate to reach out if there are other questions as they if they come up. Be more than happy to answer them. You can reach us via email at info@appviewx.com. I'm going to post my email address if you have any questions directly of me, and that's glenn@appviewx.com. Just posted within the web session. Actually, sorry, I didn't post that to all attendees. So, but as I was saying, if you have questions, if you would like a more focused demonstration or focused discussion, we'd be more than happy to schedule a Zoom meeting with your organization to help educate you and get an understanding of how AppViewX can help you manage your certificate inventories. With that, I want to again thank you and look forward to speaking with everyone out in the community.